So, hello everyone. I was kicked off the meeting. I hope it's working now. Here we go. I hope you can see my slides.
We see the slides, but not in presentation mode.
Now in presentation mode?
No.
No. Because I can't see you anymore.
No, they are not on presentation mode.
Are they now in presentation mode?
No.
No. Okay. Then, so I have it in presentation mode. I don't know how to fix it so quickly. Yeah, we have a full program today, and we leave it as it is then. So welcome from my side. I'm Daniela Hausen. I'm one of the co-chairs together with Paula Martinez and Gretchen Green. We are running this session on engineering RDM initiatives. And what we want to do with you today, so are the slides moving now? Do you see the agenda?
A little bit.
Okay, I think so. So a really quick introduction of the activities of the IG so far. And the main part will be 4 interesting presentations on engineering RDM initiatives. We will start with the German National Research Data Infrastructure for Engineering by Rainer, and then coming next, Nicola with Fair Data Collective, Fair Made Easy. Then we are having a presentation about advancing fair and open data practices in energy science, active items to progress from the status quo by August, and Valerie. And the last presentation will be by Jan about additive manufacturing, data management, and standards development based on FAIR principles. And then we have a really short time for next steps and discussion. So what we did last year and what we do this year already. So last year we focused on metadata, and we were running an online seminar series about exploring annotation and metadata initiatives for engineering data. We had 4 online seminars with 11 speakers, and the presentations and the recordings could be found at our repository of the IG site. IG website. We would like to continue on this topic, but there are still volunteers needed. So when you're interested in moving forward with this topic, please let us know. Yeah, and we are happy to help then, or going the way with you. The other focus is on data management plans for engineers. So we are continuing our work in the working group on discipline-specific guidance for DMPs. Here is the aim to develop a discipline-specific guidance to create a common understanding. And here is the focus from our perspective, the engineering part. The working group has 40 members, and we have a public meeting every 8 weeks. And you can see our working plan, and we are quite in phase 2 and 3. So this is overlapping. So we are working on a survey already, and yeah, this will come out by the end of May or the beginning of June. So now I would like to hand over to Rainer, who will give us a short presentation of the NFDI for engineering.
Daniela, may I interrupt between Rainer put the presentation up? We will be taking questions after each presentation. And then at the end of all presentations, we would like to open up again the floor for questions. If you have questions about the presentation of Rainer or any other presenter, please put them in the Q&A section. And Gretchen is taking notes in the collaborative Google Doc. So we have been pasting the link there. Please add your name in the attendance list and enjoy the presentations. Thank you.
Well, and Daniela, thanks a lot for your for the introduction. So I will start with NFDI, which is the National Research Data Infrastructure in Germany, and especially for the engineering sciences. And first, I would like to point out what I'm presenting now and today are not my ideas. These are the ideas of a consortium, and one of the persons you might remember. You might remember Doris Wedlich. She was here in RDA in the council, and she died last year. But she was really one of the drivers of this NFDI, National Research Data Infrastructure in Germany. So let's have a look at the problem itself. Okay, we know nowadays research data management is well established. It's important. Many projects and many consortia are building research data platforms with research data management repositories and whatever it is. And three, you see here on the right side, one is a data platform of the biodiversity elixir. One is an institutional repository, rather for KIT. And one is a repository for mainly text data in Daria. So these are, of course, this here is in Europe. So these systems, which are well known and well maintained, they have, for the most part, they are using identifiers. They contain data objects. They have very, very sophisticated user interfaces for their community, and they are highly specialized, which means, so for example, they serve certain types of data objects and metadata descriptions, but they are limited. So for example, here for an institutional repository, of course, you have here kind of a data site metadata and not more. But all these instruments you're showing here are very, very valuable for research, and they're important. So, but we don't have only 3 of them. We have thousands of them. Here on the button, this is just pictured here. And the problem is that we have currently, they emerge because they are funded by projects. So in the projects, we build up such a data platform, a repository, but we don't have time and the resources to care about a big interoperability. So technical interoperability, infrastructure, common vision, and so on. So interoperability of all these data platforms and repositories will come, but we expect that the convergence is slow because of the project funding. So how can we come to a consolidation? The extreme method would be not to have such a bottom-up approach, but to do it top-down. And since we know that we are working with researchers, with scientists, top-down really doesn't work. So we need a different idea. And the idea of the NFDI in Germany is, maybe not all people will agree if I say something like this, let's build bigger silos. Let's build from these thousands of silos we have down there, one for the engineering, for the biodiversity, for culture, chemistry, and so on. So in Germany, these are funded with up to 30 of these consortia, with funding of 1.5 million per year for a duration of 10 years. On top, we have a roof organization, which is the NFDI Directorate. And in between there, we have cross-cutting sections concerning general framework and governance, technical infrastructure, legal, ethical topics, and community and user involvement. So these cross-cutting activities here are very, very important to come to a convergence and to come to a consolidation of these data platforms. And of course, to the outside, there are the links to the European Open Science Cloud, to RDA, and all the other organizations which are similar, working with it, CoData, WDS, and others. Okay, now I would like to concentrate on one part, only on the NFDI for Inc., which is for the engineering part. In the engineering, we are building up a national research data infrastructure for the engineering sciences, and the members of this consortium are distributed all over Germany. The main contributors are, of course, the 9 technical universities, but also others, large-scale research infrastructures, and so on. The objectives are going into providing training in data literacy, to foster data governance and curation, and technical solutions and methods, of course. So what is now, so to build up a community for the engineering, and we know that the engineering is highly diverse. So we have production engineering, thermal fluid engineering, material science, civil engineering, energy engineering, and many else. It took us, I think, nearly 3 years to build up ideas how we can build up a consortium and to combine somehow the engineering sciences, but they are very, very heterogeneous. So the idea was not to go over the communities, the scientific disciplines like production engineering, but to have a different approach. And this one is pretty cool. So we defined 7 archetypes. Archetypes are user orientation by employed methods, and which means, so we define an archetype Alex, for example, the name is arbitrary, which is for experiments with a high variability of hardware and research software setups. We have one archetype which takes a task and all the problems with engineering research software, with provenance tag tracking of physical samples and data samples. All the field of HPC, high performance measurement and computation with very large data. Heterogeneous data requirements, many participants in simultaneous devices, or field data, for example, these are sensor networks. So these 7 archetypes defined, they concentrate on a problem which are independent of the research field or the research discipline, that is the engineering discipline. So, and they tackle these problems which emerge, for example, in experiments. On the other hand, of course, we have base services. Base services are basic infrastructure services. So starting from quality assurance in research data management, research software development, metadata, of course, terminology services, repositories and storage, and others. And you see here everywhere where we have this RDA logo, here we are also solutions which have been created in RDA, which can be taken up and adopted in the infrastructure. Also, these base services we have here have high overlap with other projects. Just to mention here, HMC, the Helmholtz Metadata collaboration, and other things which are much bigger, like the European Open Science Cloud. Also, when we go into the base services, these also are lots of cross-cutting topics, which doesn't only touch the engineering part, but also the biodiversity and all the other consortia. So we need here the close cooperation within the NFTI with others. So one example, for example, is the authentication and authorization infrastructure, AAI. We don't want to run 5 or 6 different AAIs in Germany and Europe. So having a kind of a federation which works, this is the final target. Okay, now coming to the end, I will show you the all task areas of the NFDI for Inc. You have already seen here on top the archetypes for the scientific problems or scientific data problems. On the other side here, we have the user orientation by research discipline. So here you find the construction, engineering, computer science, material science, and so on. And they are here combined in a kind of task area, which is the community clusters, which ensure the communications with the scientific communities. Of course, we need management, cooperation, project management, support, consulting, and of course, what you already have seen, the base services. So I strongly believe that in trying to unify, unifying is a bad word, to harmonize is maybe better. Such a large and heterogeneous community like the engineering one, this approach which we have here with the archetypes, which are going into the direction of data problems, and from the other side, from the disciplines, that's a pretty cool idea, and it is very promising that it's work. We started now last year, and now the funding for the next 4 years, we will be evaluated, and then hopefully there will be another funding for another 5 years. Thank you for your attention.
For your presentation. Marta also congratulates you in the chat about the impressive work. I don't see any.
It's a work of the consortium. It's very, very important to point out. And just to present.
That's very good. That's very good. I don't see any Q&A. Daniela, do we have time for one question?
It will be fine.
So
if not, let's go on and
we can keep the questions for afterwards.
Yeah.
All right. Good.
Great. Then the next one will be Nicola. He's presenting Fair Data Collective, Fair Made Easy. So Nicola, the floor is yours.
Thank you. Just to share the desktop. Hopefully you will see my slides in a second. Can you see my slides? The slides, or should I start?
I can see your slide.
Okay, so thank you. So I'm going to present you an initiative that was started last year between John Grable, myself, with the advocacy and support by especially Eric Schulze, who was one of the godfathers coming up with the name of Fair Data Collective. So there was a certain pattern that emerged in the number of metadata workshops that had been run last year that were organized by Eric, and in principle there was some kind of sort of a need that we basically outlined here, and we were looking for sort of a scalable end-to-end solutions to implement fair data principles in production, and sort of tooling which is simple that anybody can use, so you don't need to be extremely nerdy about semantic web or programming or whatsoever to get you on this sort of fair data principle way, so you can go on and do your work. And in connection to the simple tools, to come up with the practical training that targets specific topics to the creation of fair machine actionable control vocabularies and metadata. So these were sort of the needs that have been highlighted through the interaction that we had last year, and then we simply, John and I, started working on coming up with this kind of life cycle of tooling that you need to use, that are there for you to basically do the FAIR principles implementation. And when it comes to the needs, and when you start transferring them to the solutions, it's basically very much about being a meticulous engineer and going from needs to specs, and then from specs actually creating solutions that will actually satisfy those specifications. And first, what we started was, of course, like dialing into the specifications for the development of control vocabularies. And this is where we basically selected specific data model, format, and representation language, which you can see here on the slides is RDF, Turtle as a format, and SCOS as a representation language. And reason why we selected those three is that RDF is a standard model for information inter-exchange on web, and Turtle is very human-readable and compact data format for RDF data, and SCOS is probably the easiest way you can start building control vocabularies before you start going more into details and become more of a semantic expert, where you can eventually switch to OWL as an option. In a similar way, we were like fixing the specs for development of metadata. And the best way to go with metadata to make the machine actionable is to basically go with linked data approach and to store your metadata in JSON LD format. LD is basically the short for linked data. And there is reasons why going for linked data. I'm not going too much into details here, but you have information on these slides. And now when it comes to the actual verification roadmap, once we have those specifications set in place, it was now about actually figure out the way how you go from 0 to hero, basically. So eventually you have machine actionable metadata, we have all those control vocabularies that you develop for your specific domain, that everything is resolvable, and that you can get the representation for humans, but you can get the representation for machines as well. And more or less, it starts with the process of building unexisting or updating existing control vocabularies, deploying those on web, then developing or updating existing or unexisting metadata templates, linking your control vocabularies with the templates, finally making those templates available so users, whether they are humans or machines, can populate them, which then leads to the creation of a metadata and finally serving the metadata themselves. So this is sort of the roadmap, and usually you do some kind of repetitive sort of in the loop the process of the first 4 steps, because you're constantly updating and improving your control vocabularies, but eventually you need to fix it. And the same thing is for metadata template. Once you dial into it, then you're ready to go to link it and actually make people, enable people to go out and actually populate and make metadata. And we selected certain tooling, and for the missing tooling we developed. For example, we created a very simple workflow for generating control vocabularies from Excel sheets and Google Sheets. And the same way we already had technology such as registration of control vocabularies on BioPortal, but additionally we built OntoStack, which is a resolver for the PIDs that terms have in control vocabularies. For developing metadata templates, we opt for Cedar, and then the connection of BioPortal with Cedar enables you to use control terms that you developed in Cedar directly. So basically, instead of having the free text inputs for your metadata fields, you're using control vocabularies, and finally you use Cedar to populate them, to create metadata, and then to serve them to both humans and machines. So solutions that we developed are, first of all, we developed a starting point with the templates. We have a generic dataset metadata template, which is domain agnostic, and machine actionable metadata template, which by developing and introducing your domain-specific control vocabularies turns to be specific to your own domain. In the same way, we come up with a very simple, we modified existing Google Sheet and Excel sheet template for developing machine actionable control vocabulary template that is then directly used in the workflows such as Sheets to RDF and Excel to RDF. And tooling, I already mentioned you about Excel to RDF, OntoStack, Cedar Workbench, BioPortal. But very importantly, we come up with training to help people get on the board with this tooling, and the process of developing semantic artifacts, which is rapid metadata for machine workshops, which are low barrier course that can train participants to build control vocabularies, to build metadata templates, or to modify them, and then eventually, basically through the course, create machine actionable metadata. So I'm just going very quickly to some of these solutions. There is lots of information on slides, and you can basically have a better look after this breakout session. So as I said, like, we have everything that we're working with. We're working very simple tools, so we don't expect people to know Git or command line or to be dedicated semantic programming whatsoever. We're using tools which everybody is used to, such as Google Sheets or Excel sheets. And one of them is, as you can see here, a simple template for building a control vocabulary, which is based on cosplay, which has certain fields that you need to fill in. and there's a very simple instruction of how to do it. And once you fill in the template, you have this whole pipeline that helps you, that runs on GitHub. And all you need to do is basically to press on the few buttons on GitHub, and the process is done automatically for yourself, such as converting those Excel sheets or Google Sheets into the SCOS turtle format that is then pushed to the OntoStack to be resolvable. So every term PID is actually active URL, and with a small configuration BioPortal, then BioPortal is able to query those new versions of the vocabulary and put it on the BioPortal database itself. And there's as I said, there is more information about what Excel to RDF and SheetStore is actually doing, what they have in the background. But importantly, just to let you know that is basically that we have quite a good group of users so far. We have a project such as Vodafone Africa and Asia, Zone Convid program, DTU Wind Energy is using them, DIKE, and International Energy Agency Wind TAS 32. OntoStack helps basically, as I said, to serve those control terms, is directly connected to the GitHub. And what it allows you that as you go with on the human side and resolve PID of a control term in the web browser, you have a very nice web page. If machine accesses the same URI, it can select whether it wants XML, RDF, or JSON LD representation of that term itself. And again, it's basically a bunch of microservices which are properly interfaced and enable you to do this. And there are several instances of OntoStack. We run one at DTU Wind Energy. There is a national one in Denmark. And then we have an international one at 2 locations, for Fair Data Collective itself and for IAA Wind TAS 32. BioPortal, as I said, among many things BioPortal is doing, the most important thing is that it's making ontology visible and accessible in the Seeder workbench. So when you're building the templates, you can actually make use of the control terms. And Seeder is a very good platform for developing machine actionable metadata. And John actually presented in one of the online seminars last year details about Seeder, but it's a very user-friendly way of developing machine actionable metadata templates and making instances of those templates. And I'm not just going too much into details, but this is one of the potential workflows that you can use a Seeder. And generic, just quickly about generic dataset metadata template, it was inspired by DataSite and DCAT schema. We turned them to be more machine actionable. And as I said, like there is lots of fields and elements, but there are only a number of them which is mandatory that can guarantee you that you get the DOI. And I'm just going to skip on one slide here is that the whole process.
Nicola, last minute. One minute.
Yes. Yeah. Sure, I'm close to finish. So the whole point is that you use those tooling to create control vocabularies for variables and subjects, and by doing this, you're turning this template into machine actionable form. You can find more details online and about rapid MFRM workshops here as well that we offer them both in Denmark and globally through Go Fair Foundation. And there is a video that shows you how all this life cycle of tools and solutions are actually used on wind energy use case. John made very nice video. And what we are going forward with this is that we don't want humans to do much of the work. We want that metadata generation is done at the point of data creation. So basically done either by data acquisition systems or software tools such as one we have and running on one of the DTU server. And will be, first, the implementation of this idea will be on the RESTful API for New European Wind Atlas microscale data service. That's from my side. Thank you.
Thank you very much, Nicola, for your great presentation. Oh, I have, yes. I see 2 questions. The first one is from Jan that asks, could metadata templates developed from various domains have overlap and conflicting definitions? How vocabularies help link them and resolve such conflicts?
I mean, yeah, but that's where it's crucial that you create control vocabularies. So you're having terms, and in your domain have specific meaning, and in that case, when you create that term, you're going to have globally unique persistent and resolvable identifier. So that term, that long URL that you're going to eventually generate, will be very specific to your domain. When you put it inside of, when you're actually creating metadata and putting, for example, as a control term for variables or subjects, that's how you can differentiate yourself. Another thing is when you build and control vocabulary through SCOS, you have ways that you can actually point to the existing term in somebody else's vocabulary, and they can do the same thing. So you create this kind of semantic ring, or indicate that this term is completely different to another one.
Mm-hmm. All right. And the second question is from Walmart. First should be easy, and this is great. Do you have any thoughts on how to get the average researchers on board with that machine actionable? That machine actionable is important.
Yeah, the big part is that since we have a templates, and the crucial part, that a crucial role the researcher plays is in building this control vocabulary, and that if they do that, programmers can eventually create tooling that can create metadata for researchers themselves, so they don't need to go and do all the clicking and writing and do the manual action. So there is lots of burden removed from their back, and basically if you make things machine actionable, it's by default then resolvable for humans, and you make much easier path for the development of tooling on top of it, because the least amount of free text we have in both metadata and control vocabulary, when we have, the easiest is to build the tools. Instead of, if you allow for too much of free text, it's very hard to build the tooling. And if your definition of the terms and the way how you name, for example, fields and template fluctuates from one day to another, that's a pretty much nightmare for building any tooling that can improve efficiency of the daily work of a researcher, and basically support staff of research as well.
And I think you also mentioned it, that in the tooling you didn't choose tools that require programming skills or
Indeed.
anything. So they are all web-based, so researchers can click, and that already makes the barrier a little bit lower for those that
absolutely. So that was our one of the key aims of John and myself, is to build the tooling, or to interface existing tools, such that researcher or anybody doesn't need to become a semantic expert overnight, or to become, I don't know, Python or Java programmer overnight, or to know the Git. Everything is like, it's built in the way that it's on Google and clickable. Eventually, you have opportunity to go make a deep dive and become a programmer, because there are APIs in many of those tools. So you can do programmatic things, and that's where this last slide I was showing, where I'm going to build a use case on the new European Wind Atlas data.
Excellent. Thank you very much, Nicola.
You're welcome.
Yeah, thank you very much, Nicola, for this impressive talk. We are moving on with August and Valerie, and they are presenting us the advancing fair and open data practices in energy science, action items to progress from the status quo. So August, the floor is yours.
Good morning or actually hello from Norway, wherever you are around in the world at whatever time right now. So let me try to share my screen with you and start with my presentation. I hope you can now see my presentation here. Is that?
We see your whole.
Yeah, but now you can see the presentation, I guess.
Now it's the presentation, yeah.
Okay, great. So I would like to present a bit about first results of the Data project, which is a project for verifying and opening data ecosystems in the low carbon energy research. And actually, I would like to take a bit the perspective of the researcher for the first part of my presentation. Because my background is research in energy science, and we are very much interested in opening the possibilities of data to steer the energy system to a more sustainable, low carbon situation. So I would like to start introducing a bit what's going on in the data system or in the energy system right now, and about the data revolution you see nowadays in the energy domain. In the good old times, it was just about a few producers basically running oil and gas power plants, and you would like to transport the electricity produced to the consumers. Nowadays, it becomes much more complicated in terms of infrastructure, in terms of the ways you produce energy, and also in the ways you actually consume and control energy. So if you're producing via wind or solar, you now rely not only on resources like oil and gas, but you also rely on weather information, sunshine hours, wind speeds, and things like that. If you think about the consumption side where people use electricity nowadays, you see a massive rollout of things like these smart meters, which measure all the energy consumption in households. You have requirements like energy passports to buildings. And of course, you have nowadays also much more complicated distribution networks in between these production sites and consumption sites. And the networks become so much like connected, not only on the small scale or national scale, but also on the international scale, that it's a real challenge to control and optimize these networks today. So data in energy science are very much on different levels of granularity. They are very heterogeneous, all the way from meteorological information to building information, to consumption accounting, and so on. And also, you would like to have some ways to aggregate this kind of data on different levels, depending on the applications you are running. There has been somebody in energy science who actually called the energy system as the biggest machine humans ever invented. And actually, it's a very large international system, which is steered by many actors. And in the old days, it was simply a one-way street from the producers to the consumers. Nowadays, you have multitudes of actors. And if you imagine a typical country, usually you have thousands of production units. You have kilometers of distribution networks. And you have, of course, like as many consumers as you have inhabitants and factories and infrastructure in a country. So if you think about the energy system, you have not only this infrastructure layer here at the bottom, but also you have the people and the machines which control this infrastructure layer. In the old days, again, it was just humans steering the infrastructure layer. So steering the production, steering the distribution grid, and steering the way energy was consumed. Nowadays, it's much more also machines who control this layer. And you're looking for a way to actually use automated data flows to control and optimize the infrastructure. And actually, in that way, also to contribute to a low carbon, more sustainable energy system, which allows us to curb climate change. And the ERA Data project is very much about making ways possible in terms of fair principles to guarantee the use of data for these purposes. And we try to standardize data governance. We try to enable metadata sharing and interoperability. We try to review and development technologies in coherence or in agreement with the fair principles and related workflows. We try to define and implement metadata standards at different levels of granularity and do this in 4 different use cases, which we have defined. There is one use case on building efficiencies. There is another one on power transmission and distribution networks. There is one on energy materials, and there is a last one on energy policies. The problem or the complicated thing in energy science is that none of these use cases are simple per se. They all come with heterogeneous data. They all come with different scales and different levels of aggregation. And actually, they all also come with different stakeholders involved. So we did in a white paper a stakeholder analysis. And we would like to provide data not only on the level of the researchers themselves, but we also see that our data should be used by, for example, policymakers who would like to see how policies are put into effect in the energy transition. We have, of course, people from the publishing departments who would like to see how results are appearing in scientific publications. We have those people who actually control the grid. And of course, we also have industry, which would like to see their products and solutions being implemented in the electricity grid. So there is a huge variety of stakeholders, and somehow metadata needs have to comply with these different stakeholders in the energy system. We try to analyze and improve the state of fair and open data in a work cycle over 3 years. And actually right now we are at the end of the first year. We already did 2 workshops on basically analyzing what data are available, what metadata concepts exist. And now we go to the second year where we would like to define workflows for verification. So verification actually put into practice, and collecting supporting technologies. And I think the developments we've just seen in the presentation of Nicola are very nice as a starting point to really see how these these technologies, these ideas work in the wild. And in the last year, we go then to sustainable models and actually see also how long-term strategies can be implemented. So in the white paper, we also collected all this information from different research going around in Europe and globally. And we derived lessons learned and recommendations. The paper itself is under review right now, but I hope it will be published in 1 or 2 months from now. And we found some lessons learned and also formulated a few recommendations. And I think the most important way to set up a working data infrastructure in energy science is that we go to common standards. This has been already stated in the first talk, and also Nicola's talk is very much about defining these standards. Of course, the standards have to be as complicated as necessary, but again, also for the common researcher, as simple as possible. And that needs supporting tools. And actually, we analyzed already a few supporting tools, also together with colleagues from GoFair. And in our work, we'll actually try to implement this and see where are the specific challenges coming from energy science. Last but not least, a few recommendations. And in the first year, we very much focused on metadata. And in the paper itself, there will be some recommendations how to align metadata at the very granular level of the research interests with metadata on the more general and aggregated level. That's one of the specific interests we have in energy science, to be able to really seamlessly to navigate between these different levels of resolution, spatially, topic-wise, and also on timescales. And I see that's one of the most important challenges also in the way machine actionability has to be implemented in energy science. We see the need to have platforms which offer a seamless access to energy data, especially for the ordinary researcher. We see the need to really put the FAIR principles into practice, but also to have a time horizon in this which is beyond the lifetime of a project and goes maybe to a decade or even more. and stressed the importance of a multi-year work program. And we would like to start actually in designing this kind of multi-year work program. Last but not least, we think that it's really crucial to put lots of funds into existing research programs to foster this kind of development. So we see the need in Horizon Europe, for example, to have like dedicated funds for supporting fair and open developments. And I think last but not least, I would like just to thank all the people which have been like contributing to these results. There will be, as I said, this white paper with more than 30 authors. And I hope the white paper will be a good source of inspiration, not only to us, but also to those who actually provide tools on the one hand side, and for other communities to follow a similar approach. And with this, thank you for your attention.
Thank you very much, Rainer. August, sorry. Too many German names today. Sorry, August, sorry. We have some questions for you in the Q&A, and I want to start, although it's not at the top, but they are related actually. So there is one question about, do you have any experience or thoughts on how to maintain the communities around fair practices? And the second question that is from Rainer, that's why I got confused. Is there a demand in RDA to create a domain-specific group representing energy science? So they are kind of related.
Yeah, first of all, I mean, I'll start with the second question because it's immediately possible to answer. So RDA already has a few ambassadors which are connected to energy science. So there is a wind ambassador. There is also somebody who's like coming from the smart grid and smart application side. It's not really covered under the one topic energy, so it's a bit more spread out in different application sites. But it would be nice really to have one common header maybe, and then have in this common building all the different rooms for all the different parts of energy science. So this would be nice to have in RDA. Coming back to the first question about like the fair implementation. What we tried, at least in the first two workshops, is engage not only like those which are very advanced in already like implementing fair. There are those communities like from pharmacy, the Wilkinson communities and so on, which are far ahead of energy science, for example, in implementing fair. And we try to invite them to our workshops. Then next principle is to actually go with the workshops where the data are. So we try to have what we call co-hosts. And these co-hosts are the big institutions in energy science in Europe. So it's also the Karlsruhe Institute, but it's also the International Energy Agency. It's the INEA, the Italian agencies. We go with our team to these institutions. It was planned a bit different, like we would like to go there physically and actually get hands to the people working there. It's impossible right now.
COVID ruined all our plans.
Yeah, so we have this online right now, but we hope actually for the end of our project to have the possibility to actually make this happen physically. And then to engage there with the researchers. So we invite like researchers which are connected to our use cases and come with their data and like try to roll out these fair implementation principles in practice. And actually in the next workshop, we try to align again with Eric Schultes and Nicola to try a bit these fair data points in our context. Of course, as I said, the real challenge in energy is somehow you don't have any simple data. Once you go into energy, it's always connected to everything else, so to say. So even if you define a simple use case in itself, it has already all the heterogeneity and the data granularity issues and so on.
Correct. Yeah. But I'm very happy that you are connecting with the work of Nicola as well and DTU. Yeah, I'm happy that the network kind of help also to bring closer different initiatives. So that's great. All right, I see Daniela, so it means we need to move to the next speaker. Thank you, August.
You're right. Thank you, August, for the exciting talk. So the last one will be by Jan, and she's presenting us additive manufacturing, data management, and standards development based on the FAIR principles. So Jan, the floor is yours.
Yes, okay, thank you. I'm sharing my screen. Can you see my screen now?
Yes, we can see your presentation. Perfect.
Okay, great. So it seems Juno is a nice platform to use. Okay, morning. Okay, actually, maybe good afternoon, everybody. So my name is Yang Lu. It's my first time to participate in RDA activities, and I'm going to talk about my domain, the data management for additive manufacturing and the standards development based on the FAIR principle. We just started the activity. Myself, I'm working for the National Institute of Standards and Technology, the engineering lab. We have an additive manufacturing program for 5 years, and I'm leading a project focusing on data management and data integration for AM. Last year, we just happened through my colleague, Bob and Gretchen. So we find this great community on the focusing on the FAIR principle. It's really just opened the door for us. I think it's a great opportunity to communicate with you, share with you our needs and some experience from our domain-specific activities. I give you maybe a very brief additive manufacturing, and many of you have heard of 3D printing, right? Additive manufacturing is a kind of actually a set of process which create an object by building it layer by layer. It's a contrary to the subtractive manufacturing, as most of us already know today, like milling, cutting, drilling. They are subtractive. You are given a big chunk of material, then you remove that you don't need based on the shape of your product. So additive is kind of you build by adding it layer by layer. There are 7 major process category, and the standard development organization, the major organizations, ASTM. So they define 7 types. So I give you just a quick view of one of the most important process we are dealing with called a Powderbed Fusion. So basically you can see that. So, oh, I'm sorry. The energy source, so here could be laser or could be electric source. And we have the raw material. Here we are powders, actually metal powders. So we have a recoating system. So we first push a layer of the powder to the build platform, then we apply laser. So after we finish the layer, based on the shape defined by the product, we pour this build platform down, we can push another layer of the powder, then you can expose laser on it again. So finally, so you sinter the powder, or by remelting the powder, you create a shape of a product. So this is a very widely used and favored by aerospace industry. So this just give you some quick example of the feedstock material, which is like a metal powders, and this is a product. So you can see this is a quite complicated shape. So the advantage of the additive manufacturing, so basically pose no limitations in geometry, and that makes the time to the market much quicker. And it's very good for small volume and high value part, and especially spare parts, right? And it can reduce the cost and produce less waste. It's good for mass personalization. The predicted market size for additive manufacturing is about $50 billion in 2027. So which means, okay, this is a very promising manufacturing technology. We are starting working on this for 10 years at NIST towards develop standards, doing research to develop standards. And we are actually supporting all varying of activities for AM development. Can see this single product development, and this two orange shows that we also support material development and machine development because of the material property. All the properties are formed during the manufacturing, so we cannot just decouple the product development from the material development, which is the true for the traditional manufacturing. Same as machine, the property of a machine or operation of the machine plays a big role in the quality of the product because of the complex geometry and localized printing. These activities actually generate big data, especially why we apply advanced technology for example, for in-process monitoring and for post-inspection, especially non-destructive inspection, created gigantic data. I will give you some numbers later. So this data has to be, managed and stored, archived somewhere, and make it accessible. So for the data analysis, in order to support the decision makings in these activities. So that comes, we have a conclusion. Effective AM data management is a practice to manage data as a valuable resource to unlock its potential for an enterprise, for a consortium, and for the whole industry. AM is still not in infancy, but it's still maturing. It's not a mature production technology. So that's the reason a lot of research there, and they keep the data, and to manage the research data is very important. The engineering community for AM, that includes not really multidisciplinary. The majority people, they are mechanical engineers, and we also have a subset branch of mechanical engineering as a manufacturing engineer, material engineers, software engineers, industrial engineers, and data engineers. So it's a very diversified community. So this kind of agrees with the data scope we are looking at. We have really multiple domains to make AM successful. The first, actually, the really well-developed domain, actually, or researched mature domain is the material domain. So a lot of data is generated from material domain, like or characterization of different material. And nowadays we have a lot of image data, microscopic images, etc. And we also have traditional manufacturing domain. That's the design domain, which is pretty, strong in the standards perspective, how do the product definition, the CAD files, and how represented this. This are all standardized. That's the good part. And for the AM system, the machines, they are very new, and also we only have like a handful of manufacturers for the AM machine systems. So there's no established practice or standards or interfaces for these systems. That is a new area. And the last and the biggest area for the data management or the data sets we are interested in, they are process data. So as I mentioned, that in-situ monitoring is applied to monitor the dynamic process. The process itself is layer by layer, involve melting, solidification, and remelting. It's very fast and very kind of complex, a lot of stochastic natures. So we put a lot of high-end sensors there to monitor that. Image-based, for example, the layer-wise image, or we monitor that individual melt pool. So this is all this black images that could be 100 kilohertz. Right now we have 20 kilohertz with like about 2 kilohertz of the picture size, and the resolution is about 8 micron. And this is a high frequency, high resolution data. And together with other like time series data, traditional manufacturing dealing with. And another big part is the post-inspection data. XCT data, we know that naturally they are really heavy. So this creates big data issue. So the volume, variety, veracity, and the velocity, it's very challenging to deal with. And the structure, a lot of unstructured data there, high dimension data. These are the data characteristics of AM data and scope. So that's pose the challenges of managing this data. So I'm just give you a quick example of how this data actually, or why this data are important. So they are important in perspective like process control, that's for individual printing. Then when we develop the part, so we have, need the data to improve the design, also to qualify the part. And for the material, we have similarly, we need to qualify material machine for regulatory area industry like aviation, like medical. So regulation requires a qualification, very strong and a strict qualification. This has to be supported by data. Okay, these are data important, and the data is kind of enabler for the successful AM or accelerated AM development. So, but the state-of-art AM management, data management are based on traditional manufacturing software like PLM, MES, material database, or some ad hoc file systems. Data is basically stored at the leaf level in an untransformed state. So it's very hard to discover, retrieve, and interpret data. And the power of AM data, we discovered that the data has to be, findable, accessible, interoperable, and reusable. That is exactly consistent to the FAIR principle. And dealing with the multi-domain data management and data findability is very, very difficult.
So Jan,
yeah,
it's last minute.
Oh, okay. I'm sorry. I need to quick. Okay. Yeah, we actually started the exploring FAIR, and these are the principles. Actually, we draw this for the AM domain. The users has to specify the metadata, and the generator has to provide metadata, and the data management professional has to make sure the data are available, identifiable, accessible, and the challenges of AM is quite different from other areas to implement the FAIR, because we still face the problem what metadata should be collected, because so many domains there. And as proprietary is an issue, interoperability is an issue, and linked data is an issue. They are all silos, and the data cannot be shared. So security is a huge big issue for the engineering community. So we develop a database, try to practice the FAIR. It's a public available database. If you have chance, you can take a look. And we put identifiers, but they are not a persistent identifier. We can make the data downloadable. And we have open database model and schema available, but it's not standardized. We provide a RESTful interface for access data. Okay. So yeah, we have the issue with, the metadata model, how to separate a doubling call type of metadata, a content-specific metadata on the medium or the data structure, and also domain-specific model. How can we include all this domain context in the metadata? So we have some current data standards activity. It's very active, focusing on interoperability. And the open OAGI, we are working with other community to develop this data model. And okay, just summarize that. Okay, data sharing and data management are critical to the AM community. So we would like to learn the best practice from the FAIR data community. We would like to leverage existing standards and tools from other application domains. And we had a FAIR workshop last year in October. We invited Eric Schutz and Mark Wilkinson as our key speakers. And we established the AM data management working group, hopefully with the community effort, build AM data commons and metadata models. So actually, you are cordially invited to support the AM community. Thank you.
Thank you very much, Jan. Sorry, it's a bit slow for me to activate my mic and my camera.
Oh, yeah, it's fine.
There are two questions for you. Thank you very much for your presentation.
Okay.
I have two questions for you. The first one is from Walmart. It says possibly a bit of out of scope of the presentation, but he's wondering, do you have any thoughts on how or when standardization under an organization like NIST is preferable to community initiatives and the other way around?
Okay. At least at NIST, right? So in the US in general, the standards development is always bottom up. So we actually support preliminary standards development. So we are doing research at NIST. I'm sorry, my dog is crazy.
No problem.
I'm sorry, just to take her. She's
No
crazy in
problem.
the morning. In that sense, so NIST actually is not standards development organization. We are doing research. We participate in the development. So the requirements initiative actually all comes from the industry. So I would say what we are doing, hopefully, is to coordinate the effort and to push some initiative. Like FAIR principles are not really well known in the AM community in the manufacturing domain. We try to, like the workshop we led, try to get people educated and introduce them to the domain. And finally, the standards, how, when that can be established or push that. So that comes from the industry.
Oh, from the industry partner.
Yeah,
all right.
yeah. So it's
The
like
second
ASTM is kind of used to be American test material and test standards. They are the primary standards development organizations for AM industry.
All right.
Mm.
And we will come back to that, actually, to that topic. But first, another question. How do you fit your metadata with regulatory requirements and processes?
Actually, right now, I would say we really don't know yet, but all the regulatory area, actually they are pretty active in develop standards. So those folks actually is leading the standards development, and for aviation and defense, right? They are actually, they already have a practice of their qualification requirements. So basically, they are putting their existing requirements into standards. But standards, we are focusing on voluntary standards, not the regulatory. I'll give you an example, right? We require, say, from the voluntary standards, we said, okay, the data delivered should comes with metadata in specific format, right? Hopefully a standardized format. But for regulatory, so they cannot demand people use. They give me example. For example, you cannot give them a Word template. So then they will get complaints about, okay, so why not PDF, right? Something like that's what some of their concerns. But the voluntary standards basically doesn't capture regulatory items. So regulatory stuff is kind of separately handled by those regulations, like Nuclear Research Council. They are dealing with nuclear products. Yeah, so that's my the limited knowledge on the regulations.
Right. Yeah. Thank you very much, Jan. And I think I would like to take 2 more minutes and ask actually a question that Jan posted in the Q&A at the beginning, and maybe all the speakers could activate their camera and their microphones. And Jan, could you stop sharing your screen,
let
maybe?
me try to see how to stop sharing.
I would like just to, because one of the reasons we established this interest group, actually, and the main challenge of engineering is that we interact with industry, where there exist some standards which are not really transferred to academia, where there are certain requirements that sometimes are not possible to fulfill by academia. And also the openness topics is also kind of challenging when working with industry. So actually Jan was asking Raina, but I think it's a valid question for all of you. Are industry actively contributing to all these efforts, or how are they involved in this? Are they providing data? Are they providing requirements? So Jan already told us a little bit about her side. So it would be interesting to know what about the big infrastructure in Germany or the more discipline-specific in climate and wind energy? Rainer, would you like to start?
Oh, well, that's simple. Of course, when talking about engineering sciences, it's closely coupled to industry. So in the German Forschungsdateninfrastruktur, we like long words. So in the
German.
The industry is not directly funded, but of course they are contributed, included in the community clusters. In the community clusters, there the connection is being made. I don't know directly. There's lots of associations together with industries and organizations. They are somehow included in there, but maybe Daniela, you know more about this because I'm directly not so coupled with industry, but the community clusters take care of it.
Okay. So there is somehow an involvement of industry through the cluster of the big platform.
Yes, it's important.
Yeah. Daniela, would you like to add something shortly before I move?
I'm so sorry, I also don't know.
Yeah, okay. Good question to answer for the next meeting.
Yes.
Right. All right, Nicola, would you like to comment? DTU Wind Energy has very strong collaborations with industry. So how are they contributing to these efforts, or how they are profiting? What do they think about this?
So basically, you're right, Paula. So we run sort of like two things in parallel. So we have this extreme collaboration with industry, which, as you said yourself, has very specific standards, and you have to provide them products in a very specific way, format, and so on. And then on the other hand, like more loose and freedom with research. So what we've been doing, particularly when it comes to the communication and language-wise, because certain standards dictates that certain variables has to be called in certain way. So what we did, we blended actually several standards in the control vocabulary of wind energy parameters that we start building. So we have sort of preferred terms and we have alternative terms, and we specifically indicate that these alternative terms are coming from specific standards. So for us, then it becomes much easier to also switch and point that we have the definitions, and at least like they're not like buried inside of some PDF, that there are links that they can access. And it's a small step, but the good thing is that in a month or so, the Wind Energy Science Conference, there will be a whole panel discussion about open data and especially involvement with industry. At the end of the day, open data, that means that somebody else paid for it and they need to see the benefit. And one way of doing it, that not all the data they collect can be processed by them. Usually you see that large companies such as Ørsted usually reach out to the academic institutes to help them in analyzing these loads of data. And we saw from there is like terabytes of data that are coming there every day, and they need help on that way to be more efficient.
Thank you, Nicola. August, your last.
Fortunately, there is also a development inside of the European Union to actually force industry or industrial actors to open up to same reporting, same standards, and so on. So we see this especially with the system operators. So there is this European network of transmission system operators. They are forced by the new directives to actually report standards and reports use of electricity, for example, on the network. And there is a way to actually align our process with these standardization efforts taken by the European Commission, for example. In addition, of course, very important in energy science, there is the reporting. So each country, of course, does its economic and also energy accounting. And we have also to comply with these national standardizations and then also the standards taken by Eurostat, for example. So this is a second important standard setting institutions beside the industrial actors like the International Standard Organization or the International Electrotechnical Commission, which are important in our field.
All right. We have 1 minute to finish the session. Daniela, do you want to say something, or should I just close up the session? There are no more questions in the Q&A, so I guess there are no more questions or comments.
Yeah, but we have 15
minutes to go.
minutes.
Oh, really?
Yes.
All right. I thought we finished at 1:30. Sorry for my mistake. Are there more questions from the audience maybe then? If you just want to open your mic or add it in the chat. No? Then, but continuing then, I have another questions. I mean, okay, how much industry know about fair data and their benefits? I guess they see this little progress focusing and so on, but what is the general, do you have any idea in your field or with the people you collaborate? What is the benefit they see besides the analyzing the big chunk of data about the FAIR principles themselves? Do you know a little bit? Yeah, Jan?
Okay. Last year, October, we had the FAIR workshop. We invite about 200 people from different subdomain areas in additive. Apparently, I think maybe really, I haven't heard of people really experience much with the FAIR activities. But when you talk about the 4 principles, everybody recognize, oh, okay, so we do have policy, we do have, some management practice for this principle, for that principle. But I don't think they really have this systematic summarizing the FAIR or the principles they have to manage their data. It's very new in our domain, especially in manufacturing area, very proprietary and IP sensitive, trade secret sensitive. People are not willing to share any data. Okay, that's my industry. So just to let you know. So that's the reason I think it's very important to learn best practice from other domains. And from government's perspective, we are supporting open data. The way that I develop my database is to develop best practice, and also it's under the U.S. government Open Data Initiative. Granting also, knows a lot about this. At NIST, we have opendata.gov. All our research data, they are in the public domain.
Wow, impressive. Somebody else would like to comment?
Yeah, what we usually have to communicate with the industry when we are talking about fair data is to straight on at the beginning say that fair doesn't mean that it's open data, because that relaxes them quite a bit, and that at least that there is a good potential if we try to come up with, if we follow similar, equivalent, or interoperable standards, that eventually they can reuse most of the tooling. I mean, that's one of the reasons why we have this massive development in the IT community, because you use the same programming language or sharing information on Stack Overflow. That doesn't hurt anybody's industry. Actually, this IT industry is fast because they can find pieces they can share and help each other to whatever, Git, Stack Overflow, and so on. So that's sort of the lesson that we learned in communicating when it comes to data, because they are sensitive. You can find the best spots for the wind farms, and if you share that, suddenly there's another wind farm next to you, and then you start stealing wind. Not a great business at the end.
All right, thank you.
Actually, from my side, so August speaking, it's a bit of the advantage that everything is getting so much more complicated that people are forced to rely more on each other. Especially in the energy business, you have so many actors nowadays that you are really risk the stability of the whole system. For example, not to have a blackout of the electrical system. So you really have to come up with standards and have to communicate the situation you are in with others to really stabilize the system. Not only experienced by the regulators, but it's also experienced by the different industrial actors. Also extending, for example, to all these developments in smart houses, smart homes. If you don't have a common standard in your smart house, it simply will not work. So in that respect, people really have to go to each other and see what are their data and how can I really ensure that everything what I would like to transmit is done in a secure, stable way.
And they are basically, industry is basically trusting the academia to do this, because They could do it themselves also.
And they did it themselves. I mean, for example, video cassette things and like standard development in these industrial applications for TV standards, for like equipment standards and so on is very much, of course, industrial driven. But on the other side, research and governments are setting the requirements. Like in the carbon reporting, for example, it's a requirement defined by the national institutions and defined by the United Nations, basically, and they have to comply with that. Also, when it now comes to like applying for funds and financial reporting inside of the European Commission, there will be these compliance reports where the standard is set by the Commission. And if industry would like to take, for example, funds from this, they have to comply to these standards. Of course, they also can steer them to some extent, but I think the first is here the Commission. There is, of course, lobbying going on as well.
All right. Nicola, did you want to say something?
No, I just wanted to say that sometimes stick is not a bad way of doing this instead of a carrot. We tried with carrot for a long time, but now we need funding agency to press, bottom, top down, so that fair goes in the right way.
Good. There is a question in the Q&A from Amy. What do you see as the next steps for this interest group? What is the useful work it can do? Communications to industry, societies, someplace else. We could make this, I guess, it's not only for the co-chairs, but I would like to hear also the thoughts of the speakers, and maybe the audience also would like to share some thoughts. How everybody see the interest group moving forward this work? Gretchen, you are also welcome to join us if you want to. Yeah, so I open the floor. So I can say that, well, we started the interest group because we saw a challenge on the knowledge about the fair data principles within engineering communities. We saw these challenges about heterogeneity of data types, as August mentioned. We saw also the challenge of working with commercial partners, industry, and so on. So that's why we initially established focus groups where we have been exploring different areas. So one, it was the work on guidance for disciplinary data management plans that Daniela is working with, which is very practical. We also did an exploration seminar series about metadata, where we got to know the work of Nicola, of August, and Cedar, and many others. And it's very nice to see that there is a kind of networking coming out of these activities. But I think Amy is right. Where do we see this going? What do we think that this interest group in RDA could help with to advance in the topic, if the audience or the panelists have any idea? I would like to hear. No, but yes, Rainer.
If I may. So looking at interest groups in RDA, interest groups are mostly communication coordination platforms. And I like it very much that you choose a topic and discuss the topic here in the plenaries. Me personally, but this is my personal meaning, and I'm not talking for RDA or for somebody else, is that if an interest group is working on building up these networks, that's really, really good. And from my point, it's also kind of sufficient, because I think that especially in RDA, the disciplines are underrepresented. I'm not talking about the computer science and the data science disciplines, but the community disciplines. We need a much stronger representation here to couple the disciplinary research or research in development in data together with the data science. And that's exactly what this group here does. And I'm very happy about this. Period.
Thank you, Rainer. Anybody else? Any thoughts?
I think we had some really nice presentations. This is Gretchen. I think the presentations today were fantastic, and really covered, you know, a nice spectrum of activity in the engineering area. And I appreciate the positive remarks from Rainer on the work of the interest group. I agree with him. I think that having these kind of communications and trying to figure out what are the common issues across different disciplines, but really with this focus in industry and engineering application areas is quite challenging. But there's definitely a place in RDA for this, because, you know, this is what our world depends on, right? In a lot of ways. You know, the successful applications that are engineered. So I think we need to kind of give some thought maybe into, is this a theme that, you know, this bridging theme between industry and engineering, academia, for FAIR? And it's not a new topic in the sense of how does industry perceive FAIR, but there could be more in-depth discussions that we can pursue along those lines.
Good. And I would like to ask maybe Nicola, August, do you see any benefit of the existence of such an interest group for your for the projects you are working on, for the work you are doing, Nicola, as a data manager, basically at DTU-Wind?
Start first. I think it's a possibility for, as you said, there are synergies and interlinks, and we can use the opportunity in the in this interest group to basically go to the practical stuff as I was showing, and maybe have a practical workshop where we try to go and build, so for example, metadata templates and jointly control vocabularies. I know it's hard, considering that Jan very nicely showed how multidisciplinary is once you get into a specific domain, and Rainer as well. But it's a good practice to start doing it, and that's why purposely I had that slide saying that without engineers, FAIR data is just philosophy. And one of the reasons that we should do it as being engineering group is to try, you know, to roll up the sleeves and try to do some work on implementing and showing some of the tooling and see what fits best in certain engineering domain. That's from my perspective. I'll be very happy to help in organizing such a practical workshop.
Nice. Great. It's a very good idea.
I can very much second this idea. All of us have something in common, and this is like doing engineering. So we use units, we use rulers, we have a way of phrasing our language. And this also finds its replication in the metadata we design. So there is something in common between like all the different disciplines in engineering, and this thing has to be developed in common. And then, of course, you can branch off into your directions from that point.
All right. Jan, would you like to add something? You are muted, sorry.
I'm muted because my dog is very annoying. So yeah, Nicola, if you want to hold a workshop, I would definitely like to support. And I think, some common, metadata for engineering, that's something I see if it's possible as some short-term, maybe mid-term deliverables. I'm just thinking about to build an engineering system, right? We are talking about engineering domain. So they share some kind of common workflow, starting from use cases and requirements, then you have design, then you construct, then you put things in use, then you kind of end of life, right? They follow certain life cycle. Data sets kind of in the temporal context. Data sets could be generated at different phases. I'm not sure if, from this kind of common dimensionality, we can do something, templates or kind of a superset of templates for the metadata. And also engineering system, we are dealing with spatial context in the sense you have big system, we have component, we have tiny, fitting interfaces. There's some other dimension I can think is any kind of template to support, representation of the design or the system at different scale and support analysis for the integration. That's just my thoughts. I would like definitely support kind of this activity from my domain. Yeah.
I'm sorry, but I lost track of the chat, and there were some discussions about assumed regulatory data is well defined, so would be relatively easy to make semantics. Regulatory data are very purely defined. For example, only very simplistic ontologies exist. So maybe there is also some ideas to continue the work of the interest group. We are missing people in the interest group. We are the co-chairs basically driving this. If you want to join actively the group to move forward one of these activities, we would be super happy that you get in touch with us. Leave us a note, maybe in the collaborative notes, and a comment in the participant list, and we will get in touch with you to move forward these ideas. There were two very good ideas, I think, looking at the standards and also the practical workshop. I think it got a lot of thumbs ups, so we could think about organizing this. Thank you. Now, am I now on time? Is now time to finish? Okay,
yes,
good.
You are.
Thank you very much, everybody, for joining us. Thank you very much to the presenters for these great contributions. I'm super happy that fair data is moving forward in the engineering disciplines. This is super exciting. And everybody keep in touch, and hopefully we can run some nice activities within the interest group. Have a good afternoon, everybody.
Okay.
Thank you.
Take care. Stay healthy.
Bye, everybody. Thank you.
Thank you.
Everybody, thank you.
Bye-bye.
Bye-bye.
Bye.